Hello everyone, welcome to Education in Hands. If we see in our last video, we discussed about what is a load and what are the different types of loads and their worst combinations according to Indian standards. Now, in this video, let us see a simple problem on the calculation of wind load using IS 875 Part 3. So first, if we see the problem, it is given like a roof truss shed is to be built in Hyderabad for an industry. The size of shed is 24 meters by 40 meters and the height of building is 12 meters at the eaves. Determine the basic wind pressure. So this is the basic type of problem in calculation of wind load. Let us solve this problem stepwise using our code IS 875 Part 3. First, if we see the important data given in this question means the roof truss shed is to be built in Hyderabad. So the location where this truss is going to be built is at Hyderabad and its size is 24 meters by 40 meters. Then the height of building is 12 meters. So these three are the important data which is given to us in the question. And now we need to determine the basic wind pressure. What is the basic wind pressure acting on the roof truss? We need to find it. So first, to calculate the basic wind pressure or design wind pressure, as per IS 875, we have the formula, that is Pz equal to 0.6 Vz square, where Vz is the design wind velocity. Vz equal to Vb into K1 into K2 into K3. So these two formulas we obtained from IS 875 Part 3 itself. Now first, to calculate the design wind pressure or basic wind pressure, first we need to calculate the design wind velocity Vz. Okay, so how we are going to calculate this design wind velocity Vz, which is equal to Vb into K1 into K2 into K3. So first one is here Vb. Vb is nothing but basic wind speed. So in Hyderabad region, we need to find the value of basic wind speed. So to calculate this Vb, we need to take the figure 1 of IS 875 Part 3. If we consider this Indian map, so here somewhere here Hyderabad will be there. So what is the wind velocity at this place? It is in blue. So we need to consider this wind velocity. Otherwise, we can also take the value of Vb from Appendix A of IS 875. Here, basic wind speed at 10 meters height for some important cities or towns are given in this table in Appendix A. So here if we see Hyderabad is having 44, which is nothing but Vb equal to 44 meter per second. So our first value, basic wind speed Vb equal to 44 meter per second. Then next we need to calculate the value of K1, which is nothing but risk coefficient. So how we are going to calculate the value of K1? Here for this value of K1, I am considering the table 1 of IS 875, where risk coefficient for different classes of structures in different wind speed zones is given as per clause 5.3.1. So in this table, if we see the class of structure, which is mean probable design life of structure in 50 years, which means the probable design life is considered as 50 years, and they gave value of K1 for different class of buildings. So first here I am taking all general buildings and structures, and design wind speed equal to 44, which is for Hyderabad we taken as 44 meter per second, and then we are going to calculate the value of K1. So for this all general buildings and structures, for basic wind speed 44, the value of K1 equal to 1. So we will take the value of 1. This is the value for K1 as per table 1 of IS 875. Next, if we see the value for K2, which is nothing but terrain coefficient. So for terrain coefficient, I am taking table 2 of IS 875 part 3. So here table 2 equal to factors to obtain design wind speed variation with height in different terrains for different classes of buildings or structures. So here height is given, to that height the value of K2 is given, but here they divided terrains into 4 categories from 1 to 4, and in those 4 categories again we are having 3 classes A, B, C. So which category we are getting and which class we are getting for this building we don't know. So according to class 5.3.2.1, 5.3.2.1, it is given like the building is used for an industry and its height is 12 meters. So building height is 12 meters and used for industry means it is belonging to the category 3. So it is given in IS 875 code. If you are not having IS 875 part 3 code, I am providing the free link in the description. Go through it and have a look at that code book. You will get a clear idea. Then in the class, if we see according to class 5.3.2.2, the greatest dimension, if we see the dimensions here, 24 by 40 are the dimensions of the building. So the greatest dimension of the building is 40 meters. So according to this class, the building belongs to class B. So terrain category 3 and class B we need to consider for our K2. And here height is 10 meters. For 10 meters, K2 value is 0.88, and for 15 meters K2 value is 0.94. But we need the value of K2 for 12 meters. Let's do the interpolation. So if we do interpolation for K2 value, which is equal to 0.88 plus 0.94 minus 0.88 by 5 into 2. So from this we will get the value of K2 as 0.904. So this is the value for K2. Then next we need to find the value for K3 for calculating the VZ. So how we are getting this K3 means we have to see the appendix C of IS 875. There the topographic factor K3 is given by the following formula, that is K3 equal to 1 plus CS. So here 1 plus CS, where C is the slope angle, which is like for 0 degrees angle the value is 0, but if the angle is from 3 to 17 degrees we need to use the formula 1.2 into Z by L, and if it is greater than 17 degrees we need to use the value of 0.36. So here I am considering like, since Hyderabad is in a plain terrain which is in Deccan Plateau, and I am also assuming the ground of the shed is nearly plain, so from appendix C I am considering the slope is 0. So I am calculating the value of K3 simply as 1 plus 0 into S, so which will be equal to 1. Then I am having all the values of VB, K1, K2 and K3. Now I can calculate the value of VZ, design wind velocity, which is nothing but K1, that is 1 into K2, 0.904 into K3, that is again 1 into VB, that is 44. So from this we will get the VZ value as 39.776 meter per second. So this is the design wind velocity, Vz equal to 39.776 meter per second. So now we got the value of Vz. It is easy to calculate the design wind pressure, that is equal to 0.6 Vz square. So which is equal to 0.6 into 39.776 square. So where we will get the value of Pz as 949.27 Newton per meter square or 0.949 kilonewton per meter square. This is the design wind pressure which is obtained by the given data. So this is a basic problem in the calculation of wind load. In the same way, at the time of K3 calculation, there may be some variations in slope, so we can get the value of C and S differently. There, we need to work more on that K3 calculation. That is a kind of complicated problem. We will see such kind of problems in design of roof trusses, where we will discuss again these wind loads and their calculations. Thank you. See you in the next video. Bye.